Welcome to Aerospace Structures. Today we'll be discussing how to perform a valve analysis. I have invited Sherez Uday, who has a master's in mechanical engineering and is world renowned in the area of product design, development, and manufacturing. He has extensive experience with CAD simulation software, and he has been helping me to guide us through some of these tutorials. We're going to learn how to import an existing geometry. In this case, it will be a valve. We'll then learn how to model a valve under internal pressure, and then we'll interpret the results. And the valve will look like this. We'll apply pressure internally, and then we will learn how to complete the modeling. With that said, I'm going to hand it over to Uday, who's going to guide us through this tutorial.
Hey guys, this is your course producer Shreyas, and today we will be running finite element analysis of a valve. I would like to thank Professor Vinay Goyal for this opportunity. So, to proceed with the simulation, once we have Ansys workbench open on your system, interface should look similar to what is being displayed on my screen right now. So, in this interface, towards the left side, we have toolbox, navigate to static structural, and double click on it. So, once we have the window which is named A open up, we can double click on engineering data to define the material. So here we can see by default the material which has been selected in the library is structural steel. Now we should leave the material as it is because we'll be proceeding with this particular material for the simulation. Now we can proceed ahead and double click on geometry in order to import the CAD model and wait for the discovery to open up. So once you have Ansys Discovery opened up, the interface should look similar to mine. In here, to import the geometry, you need to click on the top left on these three lines and insert geometry. Here, locate project 4 and you have a CAD file which has been shared with you. Click on it and import it. So basically you need to import the CAD file here which has been shared with you. So once you have this CAD file imported to Discovery, you can proceed back to the main project schematic and we can proceed with the meshing. So for that, we need to click on model, double click on it. So once you have the modeler opened up, it should look similar to what is being displayed on my screen here. Now let us proceed with the meshing. So for this particular geometry, we need to define a tetrahedral mesh. And in order to do that, first we are going to change the element order from program controlled to quadratic. And then to define the tetrahedral mesh, we are gonna right click on the mesh and insert method. And in automatic method, select the geometry and click apply. And in method, change it from automatic to tetrahedrons. So this is the condition for mesh and let us proceed to generate it by clicking on generate here. Once the mesh has been created, we can see the element size is not too fine. We can make it a more finer mesh by clicking on mesh and changing the element size to 0.02. Now let us click on generate again. So now we can see that this mesh is far better than the previous mesh. So it is very well detailed and it provides more accuracy in the solutions which we are going to run later. Now let us proceed to define the boundary conditions, and to do that click on static structural, right click on it. We are going to define the constraints. So let us introduce the fixed constraint right now. So for that, click on fixed support and select the bottom face, which we'll be fixing, and click apply. So this face has been fixed. So now we are going to apply pressure on the internal surfaces of this valve. And in order to do that, click on insert, click on static structural, insert, and then insert pressure. Select this face and apply and select the and change the magnitude from 0 to 100 Pascal. Select the geometry. Make sure that the arrow mark is pointing inward out. Similarly, we are going to select this particular phase as well. So insert another pressure, select this phase and change the magnitude to 100 Pascal. Once you have that done, now we are proceeding. Now let us proceed to define pressure on this phase and on this phase, two different phases. So we are going to apply axial pressure on the two faces which I just showed you. So the reason for that is because we are generating an axial stress which is acting outwards, which is acting perpendicular to this area. So that's the reason we are going to apply the pressure. So for that, let us insert pressure again. So let us select the top area. I zoom in this particular area, geometry apply, change the magnitude to 450 Pascal and change the direction. We can see by default it is pointing downwards, but we want it to be axially outwards, away from the structure. So let's change it to -450, which makes it outward. Similarly for this face, now let us apply another pressure. Select the surface, change the magnitude, apply it, change the magnitude to -350. Now we can see the direction has been pointing outwards. So now in the solution, we can proceed to plot the solution. In solution, what we need for this particular simulation would be total deformation, equivalent von Mises stress. Select that and click on solve. Once your solution runs, it should provide you results somewhat similar to what is being displayed on my screen. So here we can correlate the values of the color gradient with the use of the scale, or if we want to be more specific, we have a probe option in the top window here. Select probe, and if you are from your location of your cursor, you should be able to make out the values of the specific location on the geometry. To see the animation, we press play in the graph tab here, and now we are able to see how it expands due to the pressure. Similarly, this is the equivalent von Mises stresses. We press play, we are now able to see with the use of color gradients how the equivalent von Mises stress vary. So this is the end of the simulation. Now we can proceed back to original project schematic. And now we are able to see all the green tick marks, which basically means that we have successfully completed our simulation. So all the best with this project, guys. Thank you.